Hi guys, my name is Jonathan Flores and today we are going to talk about geometric gradient. A geometric gradient series is a cash flow series that either increases or decreases by a constant percentage each period. The uniform change is called the rate of change. G in this case equals constant rate of change in decimal form, by which cash flow values increases or decreases from one period to the next, and the gradient G can be plus or minus. A1 equals initial cash flow in year 1 of the geometric series, and PG is the present worth of the entire geometric gradient series including the initial amount A1. And this is the equation. Okay, here we have two figures. In figure A you can see the increasing gradient, and in figure B the decreasing gradient. And we have here an example that says a coal-fired power plant has upgraded an emission control valve. The modification cost only 8,000 and is expected to last 6 years with a 200 salvage value. The maintenance cost is expected to be high at 1,700 the first year, increasing by 11% per year thereafter. Determine the equivalent present worth of the modification and maintenance cost by hand. Okay? The PT is the sum of the three present worth components. And which ones? Minus 8,000 is the modification cost. PG is the geometric gradient and the present worth. And this part of the 200 is the salvage cost, but we have to put it in the present worth, right? So when we solve that and take into account that this minus 1,700 is A1, and that is the maintenance cost, and this 120 is the present cost of the salvage, and it's because it loses 40% of the initial value, and it's positive because it increases the value. So when we solve all, the total modification and maintenance cost is going to be the 17,999, and that's it. Very simple. Thank you guys. Have a nice day.
Hi guys, I'm John. We are going to solve an arithmetic gradient exercise for financial math. The exercise says two engineering partners borrow a large sum of money from some lenders and sign a promissory note in which they stipulate the obligation to pay in 24 months with monthly payments due at an interest rate of 42% per year compounded monthly. If the first monthly payment is for $1.5 million and successive payments will increase by 0.5 million each month. They ask us how much money did the engineers borrow and how much interest do they pay. The first thing we will do is analyze the data. Interest 42% ACM, rent $1.5 million, gradient $0.5 million, M 24 months. The unknowns are interest and present value. In this case, we use the present value equation related to the arithmetic gradient and we present two clear variables: rent, interest, gradient, and period. We solving the equation, we find the present value, which for this case is $142.96 million. Later, we find the interest that the engineers paid using the method that I show on the screen. It is a sum on rent and gradient in the 42-month period where we must substitute the previously calculated present value. Then, by the substituting the data, we know that the engineers paid $90.54 million. Wow, what amount of money! Thank you.